Welcome to solverfy.
In this problem, we're asked to consider a laser. We're given a large table, which I have transcribed right here, and we are asked to fill in the blanks. Now, I've got my first blanks that I'm going to fill in. I believe I did this one in red. And this will be calculation number 1 and calculation number 2. I can see with 632.8 nanometers, my color is going to be probably an orange red. And I'm going to go to my next page where I've already worked all these. And for my first one, I'm going to do these two calculations. So for calculation number 1, we are asked to find our, for number 1, we're asked to find frequency, and number 2, we're asked to find energy. Our frequency will be calculated by taking the speed of light divided by our wavelength, which I am converting to meters. So 632.8, and I get 4.74 times 10 to the 14th s to the minus 1. Let's go transcribe this to 4.74, and this should actually have one more sig fig in it. Good heavens, how could I have missed that? Sometimes I wonder. This is my laser. Okay, let me stick this in my calculator again. 2.998 times 10 to the 8th divided by 632.8 times 10 to the minus 9th. And that's 4.738. 4.738 times 10 to the 14th. 4.7 times 10 to the 14th. That's calculation number 1. Okay, next, this will be 738. So we're going to multiply our 4.738. I'm just going to leave the number in my calculator times 6.626 times 10 to the minus 34th, which I'm sure I did anyway. 3.139 times 10 to the minus 19th, and that'll be 3.139 times 10 to the minus 19th, and that's in joules, which I've got my headings right here, here, or my units there. Next, we are asked to find, this one I did in green, my wavelength, my energy, and my color again. This will be Calc 2. This will be Calc 3. Here, for Calc, or 3 and 4, I should say. 3 and 4. For Calc 3, we are going to take our wavelength equals C over lambda, and for Calc 4, we'll use our energy equals Planck's constant times nu again. So you can see that I've taken my wavelength, I'm calculating my wavelength by taking the speed of light divided by lambda. I get 4.876 times 10 to the minus 7th meters. 4.876 times 10 to the minus 7 meters is 487.6 nanometers. 487.6 nanometers. What is that going to be? I believe that is going to be, hang on just a second here, I'm looking up what that's going to be. That will probably be blue. Okay. So next, we found our energy by taking Planck's constant. This is in joules times our frequency. We got 4.074 times 10 to the minus 19th. Wrong way. 4.074 times 10 to the minus 19th. Then, Calc 2, that's in dark blue. We're asked to find this, and again our color. This will be number Calc 5 and Calc 6. Calc 5 and Calc 6 I did right here. We're calculating frequency and wavelength. For frequency, I take energy divided by wavelength, or energy divided by H. I'm sorry about that. H, which I've done right here. I get 5.21281 times 10 to the 14th. 5.281 times 10 to the 14th. Then, to get lambda, it'll be speed of light divided by our frequency, which I've done is 5.677 times 10 to the minus 7, and that's 567.7 nanometers. This will be green. I'm assuming 550 is green. Last but not least, this is pink. We'll be doing calcs 7 and 8, where we're calculating frequency and energy. Here's 7 and 8. Frequency will be calculated by taking the speed of light divided by our lambda, and I get 4.517 times 10 to the 14th, s to the minus 1. Next, our energy will equal Planck's constant times our frequency. We get 2.993 times 10 to the minus 19th joules. 2.993. And this again will be, this will be a little bit more, this will be red. Okay, and that should be good.